Hello, my name is Daniel, and today we will be going through the AMC 10A from the year 2020, so let's get started. First problem, what value of x satisfies this? Okay, so for us to get x, we can just put this over there, so that will be 5 over 12 minus 4 over 12 plus 3 over 4, so that's 9 over 12. So this equals 5 plus 9 minus 4 over 12, which equals 10 over 12. This is 5 over 6. So the answer is E. Number 2, the numbers 3, 5, 7, A, B have an average of 15. What is the average of A and B? Okay, so since their whole sum is 15, so 5 times 15 equals A plus B plus 3 plus 5 plus 7, which is 15. So 4 times 15 equals A plus B. And then so the average of A and B is A plus B divided by 2. So this divided by 2 equals 2 times 15. This equals 30. So the answer is C. Number 3, assuming A is not 3, B is not 4, and C is not 5, what is the value in the simplest form of the following expression? This one. Okay, so first we can see that this and this have just opposite signs. So this is -1, and then the same thing, this is also -1, this is also -1, so these are all multiplied together, which makes -1. So the answer is A. Number 4, a driver travels for 2 hours at 60 miles per hour, so that means the driver went 120 miles total, during which her car gets 30 miles per gallon of gasoline, so she needs 4 gallons. She's paid $50 per mile, so she is paid $60 in total. So she's paid 50 cents per mile, and her only expense is gasoline at $2 per gallon, so this is $8, right? What is her net rate of pay in dollars per hour after this expense? Okay, so 60 minus 8, this is 52, right? So this is $52 for 2 hours, right? 2 hours. So per hour, this is 52 divided by 2. This equals 26. So the answer is E. Number 5, what is the sum of all real numbers x for which this is satisfied? Okay, so we can have two possible ways. X squared minus 12x plus 34 can actually equal 2, or the same thing, x plus 34 can equal -2, right? So if the first one is true, then this gives us that x squared, so that just gives us that x squared plus 12x plus 32 equals 0, and so this will give us that x minus 4 and x minus 8, right? So x can be 4 and 8, and for this one, -2, then that will be, so this will be 36 plus 36 equals 0, and so here this will be x minus 6 squared, and so this means x equals 6. So we have 3 possible values, 4, 8, and 6, right? Okay, so this is 18 in total. The answer is C. Number 6, how many 4-digit positive integers, that is integers between 1000 and 9999, inclusive, having only even digits, are divisible by 5? Okay, so we have 4-digit positive integers, but they have only even digits, right? So they must be 0, 2, 4, 6, or 9. No, 0, 2, 4, 6, or 8, right? And they have to be divisible by 5, so the last digit must be a 0, and we can have any value for the other 3, right? And so the first digit can't be a 0, so this kind of 2, 4, 6, 8. But then the other 2 digits, they can be anything. So they can be 0, 2, 4, 6, 8, 0, 2, 4, 6, 8, right? So this is 4, this is 5, this is 5. So that's 4 times 5 times 5 equals 100. So the answer is B. Number 7, the 25 integers from -10 to 14 inclusive can be arranged to form a 5 by 5 square, in which the sum of the numbers in each row, in each column, and along each of the main diagonals, they are all the same. So what is the value of this common sum? Okay, so we have like a 5 by 5 square, right? Like that, right? And then the whole sum of this is going to be the sum from -10 to 14. Right, but then this sum is equal to 11 plus 12 plus 13 plus 14, because -10 all the way to 10, this just becomes 0, right? So our sum is 11 plus 12 plus 13 plus 14, which is 50, right? So the sum of this whole thing is 50, and it said that the sum of the numbers in each row and column and main diagonals, they're all the same. So what's the value of this common sum? So we have 5 common sums for each of these, right? And so 5 of these common sums, 5 times common sums, this is equal to 50, right? Because 50 is the sum of the whole thing. So the common sum, this is going to be equal to 10, right? So the answer is C. Number 8, what is the value of this thing, right? Okay, so if you see here, this is plus, 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 and we have minus, plus, 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 minus, all the way to plus, 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 minus, right? And so since we know this pattern now, we can just write 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 all the way to, and then plus 198 plus 199 plus 200, right? Because this will be the sum of all the numbers from 1 to 200, and so it will be 200 times 201 over 2. So this is 20100, right? But then the difference between these two are in the fourth numbers, right? So it's 4, 8, all the way to 200. But then we have 2 of each, so the difference is going to be 2 times 4, 8, and then what is it? 12, 16, all the way to 200. So this is 8 times 1 plus 2 plus 3 plus all the way to 50, right? And so this is 8 times 50 times 51 over 2. So this is 4 times 50, 4 times 50 times 51, right? And so the value is 20100 minus this much, and so this is going to be 200 times 51. So this is 10200. So that value will be this value, which is 20100, minus this value, which is 10200. So this is going to be 9,900. So the answer is B. Number 9, a single bench section at a school event can hold either 7 adults or 11 children. When n bench sections are connected end to end, an equal number of adults and children seated together will occupy all the bench space. What is the least possible positive integer value of n? Okay, so let's say that each bench has 77 spaces, right? And each adult gets 11 spaces, and each child gets 7 spaces, right? And so we need an equal number of adults and children seated together to occupy all of the bench space, right? And so we have 7. Yeah, so that means for the very least we can have 11 benches for the adults, right? For the adults, and we can have 7 benches for the children, right? 7 benches for the children, right? Because here there will be 77 adults, because 7 adults in one bench, and this would be 77 children also, because 11 children at one bench, right? So this is the minimum number, so 11 plus 7 equals 18. So the answer is 18, it's B. Number 10, 7 cubes whose volumes are this much cubic units are stacked vertically to form a tower in which the volumes of the cubes decrease from bottom to top. Except for the bottom cube, the bottom face of each cube lies completely on top of the cube below it. What is the total surface area of the tower, including the bottom, in square units? Okay, so let's first draw a diagram of this. Okay, so this will be our diagram, and although like all these have to be cubes, they don't look like it because of space. And so first of all, we have to notice that these are all cubed values. So this is 1 cube, 2 cube, 3 cube, 4 cube, 5 cube, 6 cubed, and 7 cubed, right? And so that means that the length of each of these cubes, they are 1, 2, 3, 4, 5, 6, 7, right? So this is 1, 2, 3, 4, 5, 6, 7, and this is also 7, and this is also 7, right? And then the next thing is that look at these kind of top faces, right? And so the top faces that are visible, if you add them all up, then you find that they are just the same thing as just like having one big square of side length 7, right? Because this comes down to go like this, and that comes down to come like this, come down to like this, and like this, and like this, and like to finally like that, right? And so that area, yeah. So the top and bottom areas, they are equal, right? Because the bottom of this thing, that's just 7 by 7, right? So this is 2 times 7 by 7. This is 49 times 2, which is 98, right? And then next we have to worry about the sides, right? And there are 4 sides, right? So sides, this is 4 times, and then we have each of the side lengths, right? So this is, so it's 1 square plus 2 square plus 3 square plus 4 square plus 5 square plus 6 square plus 7 squared, right? So it's 1 square plus 2 square, so it's 4 plus 9 plus 16 plus, what is it, 25 plus 36 plus 49 plus 60, yeah, plus 49, right? And this is equal to 4 times. If we add all of these up, then this gives us 140, and so this is 560, right? And so we have 90, so we have 98 plus 560, and this all together is 658. So the answer is B. Problem number 11. What is the median of the following list of 4040 numbers? So this is the list of 4040 numbers, and looking at this, we want the median, right? And so we want the 20/20th and the 20/21st numbers, right? And then for this one, then we need so then we need to find how many squares are below 2020, right? And so since we know that 45 squares equals 2025, and if you don't know that, I recommend you know that. That means 44 squared is going to be less than 2025, and obviously it's going to be less than 2020, right? And so that means that there are 44 numbers below 2020, right? And so that means that since 44 squared equals 121 times 16, which is 1936, right? That means the numbers from 1936 all the way up to 2020, they will just be 1936, 1937, 38, 39, all the way to 2020. Like, there is no interruption of a square between them, right? And this is more than 44 spaces, and so we can safely say that the 20/20th number, so the 20/20th, let's move this, so the 20/20th number is going to be 2020 minus 44, and this is 19, so yeah, so that is 1976, right? And that's because since there are like 44 powers of 1, 2, 3 all the way up to 44 before 2020, and so so the 20th number would be 1976, right? But we also want the 2021st number, so the 2021st number, this would be 1976 plus 1, which is 1977. And so the average of these two numbers, that is 1976.5. So the answer is C. Number 12. Triangle AMC is isosceles with AM equals AC, medians MV and CO are perpendicular to each other, and MV equals CO equals 12. What is the area of triangle AMC? Okay, so to do this, we have to draw two lines, and so one is between U and V. Yeah, so one line is going to be between U and V like that, and the other is going to be between P and A like that, right? And since AM equals AC, so these two lengths are equal, and MV and CO are medians, right? So that means this length and this length is equal, this length and this length is also equal, right? And then since AM equals AC, that means these four lengths, they are all equal to each other. And it said that means MV and CO, they are perpendicular to each other, right? Okay, so this would be a right angle, and this would also be a right angle, right? And MV equals CU equals 12, right? Okay, so since they are medians, then that means that their intersection points, this is the centroid of the triangle, right? So that means this to this length will be 1 to 2, and this to that length would also be 1 to 2, right? So since this whole thing is 12, and this to this is 1 to 2, that means PU length is going to be 4. And CP length is going to be 8, right? And same for VP and PM. This is also 8, like that, right? And so we want the area of triangle AMC. So we want the area of the whole triangle, right? And since we know this area, and this area, and this area, right? And we also know this area. Then we can get the entire area of this isosceles trapezoid, right? So UVCM, and to get that, we just have to multiply this by this by 1/2, right? So CU times MV times 1/2, this equals 12 times 12 times half equals 72, right? So this much is 72. But then since these are equal and these are also equal, that means that the whole triangle AMC, this will be 4/3 of UVCM, right? Yeah, so basically this is going to be 1/3 of this area. And since we need the whole of that area, we will do 4/3 times 72, and that is 96, so the answer is C. Number 13, a frog sitting at the point 1, 2 begins a sequence of jumps where each jump is parallel to one of the coordinate axes and has length 1, and the direction of each jump, up, down, right, or left, is chosen independently at random. The sequence ends when the frog reaches a side of the square with vertices 0, 0, 0, 4, 4, and 4, 0. What is the probability that the sequence of jumps ends on a vertical side of the square? So our grid will be drawn like this, right? And so if we put our grid like that, that means the frog is sitting, yes, so if this is 0, 0, then our frog is sitting at this point, 1, 2. And we want it to end up on a vertical side of the square, so one of these two lines, right? And so from here, yeah, so from here we have 4 ways. The frog can go up, the frog can go down, the frog can go right, the frog can go right, right, or it can go left, right? Or it can go left, right? And if you see going up and going down, this is going to that point and this is going down to this point, but then they are the exact same thing, right? Because they are just like backing up into like a corner, right? And so let's just put these into traveling vertically. So we have vertical travel, or right or left, right? And so first let's go with the left one. If the frog is going to go to the left, then like it just automatically ends up on a vertical side of the square. So what we want is done. And so the chance of getting a left is 1/4. So it's 1/4, and that's just it, right? So we have 1/4, and for the probability of getting it, and the probability of going up on a vertical side of the square after we go right. But then if we go right, then you will find that we are at the center, right? And so at the center we have equal probability of going onto any side, and so that will give us half probability, right? And so going to the right itself is 1/4, and then from there going to a vertical side is 1/2, so times 1/2. And then lastly, the vertical, I forgot a C here, vertical, right? Yeah. So lastly, the vertical route. For that, we are here or here, and they are just the same thing. So let's just say that it went here, right? And so this is 1/2, right? Because the probability of going up or down out of 4 is 2/4, which is 1/2. And let's see, from here, we have equal chance of going here or here, and we also have equal chance of going here or here, right? But then if you look at the blue possibilities, they have equal chance of either ending up on a vertical side or not ending up on a vertical side, right? Also, if you look at the green arrows, then they are symmetric by this line, and so you can also see that they have an equal chance of reaching a like red line, like a vertical line, or a horizontal line, right? So those all have just equal probabilities, and so that's just going to be 1/2. So this is just going to be 1/2 probability for it to reach a vertical side. And so we just have to add all these up. It's very easy. So this becomes 1/4, this becomes 1/8, and this becomes 1/4. And so if we put all these up, this equals 2/8, and this equals 2/8 also. And so if we add up these three, then we will get 5/8. So the answer is B. Number 14, real numbers x and y satisfy x plus y equals 4 and x times y equals -2. What is the value of this thing? Okay, so first thing that we have to do is we have to get these together and these together. So that will give us all over x2 and x cubed plus y cubed, and then plus x cubed plus y cubed over y squared. So yeah, no, that has to be a cubed, yeah. And so if we put the x cubed plus y cubed together, this will give us x cubed plus y cubed times x times 1/x squared plus 1/y squared. And so 1/x squared plus 1/y squared, that becomes, Yeah, so that will become x squared plus y squared over x squared y squared. I'll just write it on the left. So that is x squared plus y squared times x, so times all x squared y squared, and then x squared plus y squared, right? And since we know these things, we can separate this now. And so this will become, so I'll put this in red. So this is going to become x, so this is going to be x plus y cubed minus 3xy times x plus y, right? And then this multiplied by xy squared, because that's x squared y squared, plus and then x squared plus y squared, that is just x plus y squared minus 2xy, correct? And so since we know everything in this, and we know these, we can just plug them in there, right? And so this will be equal to x plus y squared, x plus y cubed, so that's 64, and then minus 3 times xy, so that's negative 2, so I'll just make it a positive times 2, and then x plus y, that's 4, and then this times, we have this, and so that will be all over xy squared, which is all over 4, and then x plus y squared, which is 16, minus 2xy, so that's plus 4. This gives us, it's 64 plus 8 times 3, so that's 24, so 64 plus 24 equals 88. This is 88 times 4 over 20, which is 5. So this is 88 times 5. This is 440. So the answer is D. Number 15, a positive integer divisor of 12 factorial is chosen at random. The probability that the divisor chosen is a perfect square can be expressed as m over n, where m and n are relatively prime positive integers. What is m plus n? Okay, so first of all, let's dissect 12 factorial. So 12 factorial is 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9 times 10, 2 and 5, and then times 11 times 12, and that's it, right? And so we have, if you see here, we have 10 2's, so we have 2 to the 10th power, 2 to the 10th power, 3 to the 5th power, 5 to the 2nd power, 7 to the 1st power, and 11 to the 1st power, right? And so if you see, we have, how many divisors do we have? We have to do 10 plus 1 plus 1 plus 1 plus 1 plus 1, so that would be 2 to the 11th power. Yeah, so that would be 11 times 6 times 3 times 2 times 2, right? But then the probability that the divisor chosen is a perfect square. Okay, so for the divisor to be a perfect square, it would be something like, the biggest perfect square that this can make is 4 to the 5th power. That's just this, right? And then 3 to the 5th power can give 9 to the 2nd power, right? And then this can give just 25 to the 1st power, right? And so this, so these are all perfect squares. And, so the factors of this number will all be perfect squares. And so if you see how many factors this has, then we have to do plus 1, plus 1, plus 1. So that's 6 times 3 times 2. So that's 6 times 3 times 2. Oh, and here we cancel everything. So this is 1 over 22. So the answer is 1 plus 22 equals 23. So the answer is E. Number 16, a point is chosen at random within the square in the coordinate plane whose vertices are 0, 0, 2020, 0, 2020, 2020, and 0, 2020. The probability that the point is within d units of a lattice point is 1/2. A point x, y is a lattice point if x and y are both integers. What is d to the nearest 10th? Right. Okay. So these numbers, they don't really matter because 0, 0 to like 2020, 0, they are like all just lattice points, right? So if this is 2020 and this is 2020, and so there are like 2020 like grids in here, right? And so so if you see here, the probability that the point is within d units of a lattice point inside every one of these squares, and so the probability for every square, for every unit square, they will be equal, right? And so d that we get for the whole square is equal to the d that we get for just this one square, right? So now let's focus on just one square. And so if we have one square, so this is going to be like 1 unit square, like that, right? And then and then the probability that the point is within d units is 1/2, right? And so these would all be lattice points, right? and so the probability that this has to be within d units, and so d would be something like this, right? And so if this length is d, then this much would be where the point is within d units of a lattice point, right? And this is going to be on all four corners. And so if you see, you can add all these up to make one full circle, right? And we know that this combined area right here of the spheres, right, this is 1/2, right? Because that's the probability that the point is within d units, because we know that the full area is 1, right? And so the full area over the circle area, this equals 1/2, right? But then since the full area is just 1, that means just the area of the circle, that's just 1/2, right? And so we know that this much is d, right? And so we can say that 1/2 equals pi d squared, right? So d equals 1/2 times 1 over pi. So this is 2 pi, no, so this is 1 over 2 pi, right? And then this is going to be like 1 over 6.28 because pi is like 3.14. And we know that this is similar to 1 over 6, which is basically 0.166666666, something like that, right? And we know that this, so 0.16, this is equal to 0.4 squared, and so the square root of this, sorry, this should be d squared, right? And so the square root of 0.16 is 0.4 squared, so the root of this is the root of this is similar to the root of this is similar to the root of this is equal to the root of this, and so this would be d, right? And so the root of 0.4 squared would be d, so d is similar to 0.4, right? So what is d to the nearest tenth? Our best estimate is 0.4. It's b. Problem number 17. Define px equals this. How many integers n are there such that this is okay, right? So for this to happen, either 1 is positive, yes. So if you see, there is 100 there is 100 numbers multiplied in total, and so the number of ways that this can be negative or 0 is that this is 0, or like this is positive and the rest is negative, or the first 3 are positive, so the first 3 are positive and the rest are negative, or the first 5 are positive and the rest are negative, and so on, with all numbers being positive and the rest being negative, right? And so if we just like write this down, that means that we want the integer n, right? So n is going to be greater than or equal to 1 and less than, greater than or equal to 1 squared, and less than or equal to 2 squared, right? Since that would make this value negative and the rest will be positive, right? And so this is one possibility, and we have the equal sign because if this is 0 or if this is 0, then this is also satisfied, right? And so that's also correct. And by the same way, for the first 3 to all be negative, then no, sorry, for the first 3 to all be positive, right? Then we want n to be between 3 squared and 4 squared, right? Same thing for n. And it's 5 positive numbers, n is greater than or equal to 5 squared and less than or equal to 6 squared, right? And so on until n is greater than or equal to 99 squared and less than or equal to 100 squared, right? Okay, so let's look at each of these values. For this one, we have 1 plus 2 squared minus 1 squared. And so same thing here, since there is equal sign on both sides, we have to do 1 plus and then 4 squared minus 3 squared. And the same thing for here, 1 plus 6 squared minus 5 squared, and same thing, so on, until this becomes 1 plus 100 squared minus 99 squared, right? But then if you see this whole row, this whole region, that becomes, this is 2 plus 1 times 2 minus 1. This is 4 plus 3 times 4 minus 3, and this is 6 plus 5, 6 minus 5, all the way to, this is 100 plus 99 times 100 minus 99, right? But then if you see, these are all 1, so these can all be disregarded, so they are all 1, so they are not important. And this gives us the sum from 1 to 100, right? Because 1 plus 2 plus 3 plus 4 plus 5 plus 5 plus 6 plus all the way to 100. And so that gives us all the values from 1 to 100. And so let's write that down. So this much values, they would give us 1 to 100 sum, right? So this is 100 times 101 over 2. And if you look at the leftovers, which is all these ones, then that gives us, this is 50 numbers, right? So this is 50 ones, so that's just 50. And so how many integers n are there? Then we have to add this number and this number, right? And so first let's simplify this. This becomes 50 times 101. This is 5050, right? So what we have to do now is add 50 and 5050. And so if you add them together, that will become, that will become 5100. So the answer is E. Problem number 18. Let A, B, C, D be an ordered quadruple of non-necessarily distinct integers, each one of them in a set 0, 1, 2, 3. For how many such quadruples is it true that A minus D, notice that A times B minus B times C is odd? For example, 0, 3, 1, 1 is one such quadruple because this is odd, right? Okay, so the only way that this can be is that A times D is odd and B times C is even, or A times D is even and B times C is odd, right? Okay, so for one to be odd, and one to be even, right? Then there are 16 total possibilities because there's 4 because they are in the set 0, 1, 2, 3 and they are not necessarily distinct. So that's 4 squared equals 16 total possibilities. And for one to be odd, right? So for one to be odd, this is just either 1 or 3. So it's 2 squared equals 4 possibilities, right? And for even, this is all the rest. So 16 minus 4 equals 12 possibilities. So for odd we have 4, so for even we have 12, and so we have so if AD is odd and BC is even, then this will just give us 4 times 12, and same thing for here, that will just give us 4 times 12, 12 times 4 since the order is reversed, but that doesn't even matter. So since we add these together, it's 2 times 4 times 12, this is 96, so the answer is 96, it's C. Number 19, as shown in the figure below, a regular dodecahedron, the polyhedron consisting of 12 congruent regular pentagonal faces, floats in empty space with 2 horizontal faces. Note that there's a ring of 5 slanted faces adjacent to the top face and a ring of 5 slanted faces adjacent to the bottom face. How many ways are there to move from the top face to the bottom face via a sequence of adjacent faces so that each face is visited and most ones that moves are not permitted from the bottom ring to the top ring? Okay, so first of all, we can divide this dodecahedron by this line right here, and this will also go over to the to the other side like that, right? And so if we divide by that ring, then that means that we will get a top side this much and a bottom side this much, right? And so we can have the top side like this, and so there will be a top one and there will be 5 surrounding it, the sides, and then the bottom will look the same with 1 at the center and 5 surrounding it, right? And so it asked how many ways are there to move from the top face to the bottom face by a sequence of adjacent faces, right? So we have to start with the top face. So we start at the top, and then we want to choose where to go. Where to go out of these 5 so out of those 5 pentagons, right? And so out of 5 we choose 1, so this is 5. I'll do that in a different color. This will be 5. And then after that we have to choose how to go there, right? How to go, right? So let's say that we chose this one. So this is where we are going to go after the top face. And so obviously we could like just go right away like that, but then we can also have other ways. We can go like this, or we can go like around there like that, right? And so the number of ways that we can go is 1, 2, 3, 4, 5, and then so that is going counterclockwise, and then when we're going clockwise we have 1, 2, 3, 4, right? So we have 9 in total, so that will be 9, right? And then after we chose here, let's say that face is this face, right? But then now we have to choose to go to the bottom face, right? So from the top to the bottom we have to move, right? But then we have two choices here. We can go to here or we can go to there, right? So we have two choices, and so choose how to go down, choose how to go down, and that will give us two choices. And then lastly, let's say we chose somewhere like here, right? And then we have to get from this bottom to the very bottom, right? And so we have to choose how to end, right? And the number of ways that we can go from here to here is the same as before here, right? So that will be just we can go right away, that's one, or we can go clockwise like this. So 1, 2, 3, 4, or we can go counterclockwise, right? And so counterclockwise, that would be like from here, like 1, 2, 3, 4 ways. So we have 9 ways in total also, and so this will also be 9. That will also be 9. And so lastly, we have to just multiply all of these together. So 5 times 9 times 2 times 9 equals 10 times 81, which is 810. So the answer is 810, so the answer is E. Problem number 20. Quadrilateral ABCD satisfies ABC equals ACD equals 90, AC equals 20, and CD equals 30. Diagonals AC and BD intersect at point E, and AE equals 5. What is the area of quadrilateral ABCD? Okay, so first we have, let's draw this diagram like this. So this is what we have, quadrilateral ABCD, and as you can see, this angle is 90 degrees, that's ACD, and ABC is also 90 degrees. And AC is 20, so this much is 20, and CD is 30. Let's write this down, 30. And diagonals AC and BD intersect at point E, so this would be point E, and AE equals 5. So since AE equals 5, then EC would equal 15, because AC, the whole thing, equals 20, right? And so EC would equal 15. And then now we will get the problem started. What we have to do is we have to draw a line from B to the like the right angle point of AC, right? So let's say that this length, let's say that this length is A. So if this is A, right, then AE, the whole thing is 5. So the length from here to here, so this length, that will be 5 minus A, right? So that will be 5 minus A. And so that's this length. And then we can now see that this triangle, so triangle DEC and triangle BE to this new point right here, those are similar triangles, right? And then now we can see that this length to this length, the ratio is 1 to 2. That means this to this ratio is 1 to 2. And so this length will be 2 times A. So that will be 2A, right? And then lastly, since this is a right angle, we can focus on the fact that this triangle and this triangle, they are similar, right? Because they came from the same right triangle. And so we can say that the ratio of this to this is equal to the ratio of this to this, right? Because they are similar and they have the same ratios, right? So 5 minus A over 2A, so that's for this so that's for this one. 5 minus A over 2A, this is equal to 2A over 15 plus A, right? Because this is 2A and this is 15 plus A. And so if we do that, then if we cross multiply, it will give us 4A squared. Yeah, so 4A squared, so that's this one. 4A squared equals 15 plus A times 5 minus A. So that is 75 minus 10A minus A squared. So this is, so 5A squared plus 10A minus 75 equals 0. And so if we divide by 5, A squared plus 2A minus 15 is going to be equal to 0, right? Let's move this up a little bit. So if we move it like that, and like that, so we have A squared plus 2A minus 15 equals 0. And if we factor this, then this will give us 1, 1, and 5, 3, and the negative sign will go here. And so a can be 3 or negative 5, right? But then since a is a length, of course a is not negative 5, so a is going to be equal to 3. And so what is the area of the quadrilateral ABCD? We can get that area since, first of all, we know the, first of all, we know the area of ACD. Let's just write that down first. ACD, this equals 20, that's AC, times 30, that's CD, times 1/2, equals 300. And now we know ABC. ABC, let's do that in green. ABC, this much is 20, so AC is 20, this is 20, times, and then this much is 2A, right? So 20 times 2A times 1/2, and so that's just going to be 20 times A. And since A is equal to 3, we can erase A and put in 3, so this is 60, right? So if we add 360 together, we get 360, so the answer is D. Number 21, there exists a unique strictly increasing sequence of non-negative integers a1 all the way to ak such that this is satisfied. What is k? Right. Right. So the first thing that we have to do is notice that 289 is 17 times 17. So 289 equals 17 squared. And so 2 to the 289 equals 2 to the 17 to the 17th power. Right? To the 17th power. Right? And so if we say that 2 to the 17th power is equal to a, then that means this is going to be a, so this is equal to all over a plus 1, and then a to the 17th power plus 1. A to the 17th power plus 1, right? And so we need what is k, right? And so, sorry, that should be more legible, 17, right? And so since a 17, so since a to the 17th power plus 1, this equals a plus 1 times a 16 minus a 15 plus a 14 minus a 13, and then so all the way alternating until plus a squared minus a plus 1, like that, right? And so if we divide by a plus 1, this divides by a plus 1, so this is cancelled. So this is equal to this much, right? And so a to the 17th plus 1 over 1, so that's what we want here. That is equal to, this is going to be equal to this here. That is, what is it? A16 minus A15 plus A14 plus A14 minus A13 plus A12, and then all the way until plus A squared minus A plus 1, right? And so we can now put these in groups of 2 like that, and so that will just give us so that will make us able to to take out a minus 1, right? Because this will be a minus 1 times a to the 15th, this will be a minus 1 times a to the 13th, this will be a minus 1 times a to the 11th, and all the way to this will be a minus 1 to the a, so that will be a minus 1 times a, right? And so if we do that, that will be a 15 plus a 13 plus a 11 all the way up to a cubed and then a, right? And then we have this one left over because we put them in 2's, right? And then so we had 1 left over, and so this is just plus 1. And now we can just put in back the fact that a equals 2 to the 17th power, so this is 2 17th minus 1 times and then these would just all be separate numbers, right? Because this would be 2 to the 17th times 15th power, and then this would be 2 to the 17th times 13th power, all the way to just 2 to the 17th power, right? And so let's just say that these are like the 8 numbers. So these are 8 numbers, right? And then they will just be there, so these 8 numbers, they will be multiplied at the end, but then now we just need to care about how many numbers are there in 2 to the 17th power minus 1. And then next, so we take care of 2 to the 17th power minus 1. This is 1 to the 17th power, so that is just equal to 2 minus 1 times 2 to the 16th plus 2 to the 15th plus 2 to the 14th plus 13th plus all the way to plus 2 squared plus 2 plus 1, right? And then this times we have the same 8 numbers that we had before, 8 numbers. And then we have this one, and then this is plus 1, right? But then we want it to be in power of 2 format, but then 1 is equal to 2 to the 0th power, so we can just do that. And they just have to be non-negative, so 0 is okay, right? And then, so since this is just 2 minus 1, that's multiplied 1, so that's just 0, so that goes away. And so that gives us, how many integers do we have here? We have 17 here, we have 17 numbers here, and here we have 8 numbers, and then plus 1 number, right? Plus 1 number. And so that would give us in total 17 times 8, so 17 times 8 equals 136, but then we have to add one more number, so 136 plus 1 equals 137, so 137 is the answer is C. Problem number 22. For how many positive integers n is less than or equal to 1000 is this not divisible by 3, and x floor is the greatest integer that is less than or equal to x. Okay, so first, if this is to be not divisible by 3, then we have 3 restrictions. The first is that n cannot be divisible. N is not a factor of 998, right? Because if n was a factor of 998, then these three, they would just all be the same value, right? And so n cannot be 1, 2, 499 or 998, right? But then we have but then we have an exception here, which is 2, because if n equals 2, then this would be 499, and this would also be 499, but then this would not be 499, that would be 500, right? And so n equals 2 is possible, so not this one. N equals 2 is possible, right? And then our next restriction is that n must be a factor of 999, and that is because if n is a factor of 999, then like this would be a number, let's say it's k, and this would also be k, but then this one will be k minus 1, so those three together, that would not be a number that is divisible by 3, right? So n should be a factor of 999, and so if we see how many numbers this is, 999, this is 3 to the, so this is 3 cubed times 37 to the first power, and so this has 3 plus 1, 1 plus 1, so that is 4 times 2 equals 8 powers. But then since n cannot be 1, it should be 8 minus 1 equals 7, right? So we have 7 n's when n is a factor of 999. And lastly, our last kind of thing is that n should be a factor of 1000. That is our last condition, right? And that is and that is for the same reason. If n is a factor of 1000, then this number would be something like k, but then this would be k minus 1, and this would also be k minus 1, right? And so n must be a factor of 1000, because then this will not be so that won't be divisible by 3, right? So if n is a factor of 1000, how many numbers is that? 1000 is 2 cubed times 5 cubed, and so we have 4 times 4, so we have 16. 4 times 4 equals 16 numbers here, and so we have 16 minus 1 equals 15 numbers. So we have 15 numbers here. So we have 7 numbers and 15 numbers, and we did also say that n equals 2 is possible, but n equals 2, this is within the factors of 1000, so that is just already counted. So we have 15 plus 7, and that is 22, so the answer is A. Number 23. Let T be the triangle in the coordinate plane with vertices 0, 0, 4, 0, and 0, 3. Consider the following 5 isometries, rigid transformations of the plane. Rotations of 90 degrees, 180 degrees, and 270 degrees counterclockwise around the origin, reflection across the x-axis, and reflection across the y-axis. How many of the 125 sequences of 3 of these transformations, not necessarily distinct, will return T to its original position? For example, a 180-degree rotation followed by a reflection across the x-axis, followed by a reflection across the y-axis will return T to its original position, but a 90-degree rotation followed by a reflection across the x-axis followed by another reflection across the x-axis, that will not return T to its original position, right? Okay, so let's try to draw this triangle in case it has any meaning. And so if we see it as 0, 0 and 4, 0 and 0, 3, right? And so that would be a triangle shaped like this. And all this gives us is that it is not symmetric in any way. So it is not symmetric, right? Yeah, so y equals x, so y equals x kind of flip would have an effect. So make it different, makes it different, right? So since we have that, now we can just go on with finding the number of possibilities, right? And since it said, yeah, so since it said how many of the 125 sequences, we are just looking for how many possibilities are there and not what is the probability, right? And so first of all, we can see that the 90 degrees counterclockwise is equal to 270 degrees clockwise, and 270 counterclockwise is equal to 90 degrees clockwise, right? And so our only possible combinations, they are 90-degree rotation, 90-degree rotation, and then 180-degree rotation, or 270-degree rotation, 270-degree rotation, and then 180-degree rotation, or x-axis flip, y-axis flip, and then 180-degree rotation, because these will all get t to this point, right? And so we have to always do 180 degrees reflection. 180 degrees rotation to get it back to its first position. So first, let's look at this one, 90, 90, 180. And so this will give us three possibilities, right? Because 180 can go at the first, second, or third. And by the same reason, this will also give us three possibilities. 180 can go first, second, or third. But then here, yeah, but then this last one, all three are different. So this gives us 3 factorial equals 6 possibilities. So it's 3 plus 3 plus 6, which is 12. So the answer is A. Number 24, let n be the least positive integer greater than 1000, for which GCD of 63 and n plus 120 equals 21, and GCD of n plus 63 and 120 equals 60. And what is the sum of the digits of n? Okay, so since the GCD of this and this equals 21, right, and 63 equals 21 times 3, right, that means n plus 120. Yeah, so that means n plus 120, this is 21a, and a cannot be a multiple of 3, right? Because if a was a multiple of 3, then the GCD would have been 63, not 21. And same for this one. Here n plus 63. Yeah, so 60 is 1/2 times 120, so n plus 63 must be a multiple of 120. So this is 120n, no 120b. But then here b must not be a multiple of 2, right? Because if b was a multiple of 2, then this would have been 120, not 60. Sorry, this is not 120b, that should be 60b. Yeah, this is 60b, right? And since n is equal, then we can see that 21a, yeah, so 21a minus 120 is equal to 60b minus 63, right? And so this means that 21, yes, so if we divide everything by 3, then that gives us 7a minus 40 equals 20b minus 21, right? So 7a minus 20b equals 19. And so now we can make kind of like a table for the values of a and b, and those would give us the value of n, right? And so if we have a and b, then first of all we could have 17a and 5b, right? Because if you put this in there, then this does give us 19, and they all do match these conditions, right? So 17 and 5, they are possible, but then we now have to check if n is greater than 1000, right? And so if we check n, this is n, right? So n equals 21 times 17 minus 120, and 21 times 17, that is like barely 400, right? 21 times 17, that is less than 400, and we have to subtract from that, and so that is obviously less than 1000. So 17 and 5 can't be it, and so let's keep looking for next values. And so since we have 17 and 5 established, what we can do is we can add 20 to a, and then add 7 to b, right? Because a increases by a factor of 7, and b decreases, and b increases by a factor of 20, right? so to balance this out, if we add 20 and add 7, then that will just all be the same, and that will make it all equal to 19 again. And so that will give us 37 and 12. And if we check the conditions, sadly this is a multiple of 2, but b cannot be a multiple of 2, so that's not that's not a consideration. And the next, plus 20 plus 7, if we do that, we get 57 and we get 19. And now let's check the conditions. A is not a multiple of 3. Oh, well, 57 is a multiple of 3, right? 57 is 3 times not like 19, right? And so so this also cannot be it. And now let's look at more values. It can be 77 and 26, right? But then also the same thing, b cannot be a multiple of 2, but it is, so we skip that, and then we go to the next one. That is 97 and 33. Is 97 a multiple of 3? No. And is 33 a multiple of 2? No. Okay, so that is a plausible value, and so this matches the conditions. So let's try to get n. N equals 60, b minus 63. So if we put 33 in there, this is 60 times 60 times 33 minus 63. So this is equal to 1980 minus 63, and this is equal to 1917. 1917, right? So this is the answer. The answer is 1917. But then what we want is the sum of the digits, right? So we want 1 plus 9 plus 1 plus 7. This is 18, so the answer is 18. It's C. Last problem, number 25. Jason rolls 3 fair standard 6-sided dice. Then he looks at the rolls and chooses a subset of the dice, possibly empty, possibly all 3 dice, to re-roll. After re-rolling, he wins if and only if the sum of the numbers face up on the 3 dice is exactly 7. Jason always plays to optimize his chances of winning. What is the probability that he chooses to re-roll exactly 2 of the dice? Right? Okay, so first of all, if he rolls 3 and he gets a 7 right away, gets a 7, and he gets a 7, right? This will be getting a 7 is we can have 1 1 5, or getting 1 2 4, or getting 1 3 3, or getting 2 2, or getting 2 2 3, and there are no more, right? And rearranging 1 1 1 5, we get 3 possibilities. Rearranging 1 2 4, they are all different, so that's 3 factorial equals 6 possibilities. Rearranging 1 3 3 gets us 3 possibilities, and rearranging 2 2 3 gives us also 3 possibilities. If we add these up, this is 15. So we have 15 possibilities of getting 7 when we roll 3. And so this will give us 15 over 6 factorial over 6 cubed, right? Because we rolled 3 dice. So this is equal to 5 over 72. This equals 2.5 over 36, right? And so now let's look at when Jason actually chooses to re-roll some of the dice, right? So if Jason re-rolls 2 of the dice, then he will leave 1 alone, right? So let's see what number that he doesn't re-roll. So if he doesn't re-roll, does not re-roll 1, right? Then that means that he will roll 2 and have to get a sum of 6, and get a sum of 6, right? And getting a sum of 6, that will be what can there be? It's 1 1 and 1 5, 2 4, 1 5, 2 4 5, and then 5 4 3 2 1, like that, right? So this is 5 possibilities, so that's 5 over, and then we have rolling 2, so this is 36, right? And then comparing this to the possibility that just getting a 7 by 3, this is greater, right? So he will choose to re-roll just 2 of the dice and not all 3, and so this is possible. And if he doesn't re-roll 2, not re-roll 2, that will be he has to roll 2 and get a sum of 5, right? And for him to get a sum of 5, he can do 1 4. No, he can do 1 4, 2 3, 3 2, or 1 4. So this is 4 possibilities. So that is 4 over 36. And if you see 4 over 36 and 2.5 over 36, obviously 4 over 36 is greater. So that is also possible, right? And not re-rolling. Yes. So if Jason does not re-roll 3, right, then he would have to roll 2 and get a sum of 4, and so that would be getting 1 3, or 2 2, or 3 1. So that's 3 possibilities. That's 3 over 36, and that is greater than 2.5 over 36, so that is possible. Lastly, if we so if Jason does not choose to so if Jason chooses to not re-roll 4, that means he will have to roll that means he will have to roll 2 dice to get a 3, right? And that is only 1 2 or 2 1, so that's just 2 probabilities, 2 possibilities, right? So this is 2 over 36, and if we compare this to this, 2 over 36 is less, right? So this is not possible. So his limit is not re-rolling a 3, right? And then so finally, let's compare these. We have not re-rolling a 1 or a 2 or a 3. And so if he doesn't re-roll a 1, that means that he got values 1 something something, right? But then these values were so large that he decided to keep 1 and re-roll these 2 values, and that only probability is getting 6 and 6, right? And so rearranging this, we have 3 possibilities that will give us 3. And then similarly for this one, this will and so that will have to be 2 and then something and something, right? But this time he will re-roll if his numbers are 5 5 or 5 6 or 6 5 or 6 6, right? And so this has 4 possibilities, right? So they can be like 2 5 5 or 2 5 6 or 2 6 6, and 2 6 5 is just the same thing as 2 5 6, right? And rearranging, we get, this gives us 3, this gives us 6, and this gives us 3. So 3 plus 6 plus 6 equals 12. So that is 12. And lastly, for this one, not re-rolling a 3, that means he would have to get 3 and a value and 2 values greater than that. And so those values would have to be either 4, 5, or 6, right? And the same for 4, 5, or 6, right? So those values could be 3. So those values could be 3 4 4 or 3 4 5 4 6 or 5 or 3 5 6 or 3 5 5 or 3 6 6, right? And so these are all the possibilities. But 3 4 4, that gives us 3. 3 4 5, they're all different, so that gives us 3 factorial, which is 6. 3 4 6, they're all different, so it's a 6. 3 5 6, it's 6. 3 5 5, it's same, so it's 3. 3 6 6, it's 6 and 6 is same, so that gives us 3. And adding all these up, we get 27. Right, so this gives 27 possibilities, and so our final thing we have to do is we have to add these up. 3 plus 12 plus 27, that gives us 42, right? And 42, and it asked for the probability, and so exactly 2 of the dice. So this all over 6 cubed, right? Because he rolled 3 dice at first. So this equals, so 42 over 6 cubed is equal to all over 6 squared and 7 over 6 squared, so this is 7 over 36. So so 7 over 36 is the answer. It's A. So that was it for AMC 10B from the year 2020, and thank you for watching.